session. We are today dealing with the subject mechanics of solids for aerospace for the second year students. In the previous class, we have discussed how the sign convention will have to be followed for shear force as well as the bending moment to draw the shear force diagram when as well as the bending moment diagram. If we are having the shear force values as well as the bending moment values at each and every point. Okay, so shear force diagram, bending moment diagram is very important even we are having the values, but how to draw, that is the matter. Okay, so we know all that the thing is beam. Okay, beam have supports as well as a number of loads with the different types of loads being acted on the beams. Okay, now let's have here I have today we are going to have the nature of curvature to be drawn in the shear force diagram as well as the bending moment diagram. And here the left corner I have given that it is shear force or bending moment. Okay, when we are going to draw the shear force diagram, how the curvature with respect to the loads. Okay, so no load. Okay, let's take our region. Okay, let's take one region. Okay, so let's take A, B. The beam having supports to stake. Okay, then in between region no load or any point loads are acting. Okay, then the shear force will follow the horizontal line only. That means here let's have shear force line is a zero shear force. Okay, when we are having a point load. Okay, let's take 10 Newton. Then from that point, okay, from that point here to here, you have a horizontal line. Then there will be an increment or decrement with respect to the sign increments. What we have told earlier, that will be a vertical movement or horizontally vertical movement, maybe upward or downward with respect to plus or minus we are adding. Okay, then in this region, okay, we don't have any load, so it should be followed by a horizontal line only. Okay, so shear force will follow, shear force diagram will follow horizontal line like this. Okay, then no load or a point load acting in between the region. Then if it is UDL, when UDL load is acting, let's take here I am considering UDL. Okay, not fully. Let's take okay, UDL, that is uniformly distributed load. Then intensity of load, maybe let's take 10 Newton per meter. So don't go with the values. Now we are concentrating only the curvature, how we are going to draw. Okay, here shear force. The shear force will follow an inclined line. That means we have a shear force here one value and at the midpoint one value. Okay, and then here one value. Okay, so since this point to this point we are having UDL, so we have to directly join the value. Okay, join the value directly. So it's an inclined line, it follows instead of horizontal line. Here from this point to this point you are having the UDL, so you can join. Okay, maybe it was okay with respect to the value whether it is positive or negative like that. But don't consider here values. I am concentrating only the for UDL how what curvature it follows for this shear force. Okay. Then if it is UVL, okay, uniformly varying load. Uniformly varying load, so it will be like this. Triangle shape. It is a downward force. Then the shear force will follow. Okay, parabolic load. Okay, so it will follow a parabolic load. Y square is equal to 4ax. What we have studied earlier. So it follows that curvature. It follows. Okay. Then then come to the bending moment diagram. So when you come to the bending moment diagram, same thing. Let's have a point over here, point load here. Here I am taking values given. Here I am having value at this point. Here this point. Okay. In shear force it is a horizontal line, but here you directly join the values. Okay. So inclined line will follow. In case I am having a UDL here. So at UDL you have one value here. Okay. Then a parabolic curve. This is a parabolic curve because from this point to this point we have a UDL, uniform distributed load. So it follows the parabolic curve. Okay. Then at this point you have another value. At this point you have a point load. So the same point. So you have an increment or a vertical increment in the shear force. Then here no loads are there from this point to this point. So you have to come here, okay, and no point is there, directly join the value, inclined. So this is the linear curvature, this is the parabolic curvature for bending moment. Okay. Next, if we are having a load uniformly distributed, okay, uniformly distributed load, then what happens here? So in bending moment, okay, it will follow from this point to this point. Okay, from this point to this point, it will follow. This is cubic curve. This is the cubic curve. Okay, then you will have another point here. Okay, 10 Newton. But then you don't have any increment in the bending moment, because the load is acting at the same point. So load into perpendicular distance is the bending moment. So at this point you don't have any perpendicular distance here. Then you come to this point. This point to this point you don't have any load at all. So bending moment will follow the linear inclined line. Okay. So this is the curvature we have to follow while drawing the shear force diagram and bending moment diagram, and how to find the shear force values at each and every point, as well as the bending moment values at each and every point. We will see in the next class, and we can draw the shear force diagram and bending moment diagram. So once again I will just go and summarize. Okay. Then let's have on a beam, one region we are having that in between. Okay, we don't have any load. Otherwise, only point load is there. The shear force will follow a horizontal curvature or horizontal line. As well as for bending moment diagram, you just have an inclined line, because there should be an increment in the values of the bending moment values. So direct join, that is an inclined line. Okay. Then if you are having the UDL, uniformly distributed load, then the shear force must be, you have at A one value, at B one value. Okay, there will be a difference. It should not be equal for uniformly distributed load. So you just directly join as a straight line. Okay, so it should be inclined. For bending moment diagram, you make a parabolic curve towards positive means positive, inward, outward curve if it is negative. Okay, then uniformly variable load. And the shear force diagram will follow the parabolic curvature, as well as the bending moment diagram will follow the cubic curvature. Cubic curvature means cubic equation satisfied, x cube plus 3x, like that, and equation will be there. It will follow or satisfy the cubic equation. So like that, the sign convention. After that, the natural curvature for shear force diagram and the bending moment diagram, we have to look on it. Kindly we have to draw the diagram for the beams, whatever the beams are being given for solving the shear force values, bending moment values, and finally to draw the shear force diagram and bending moment diagram. From the diagram itself, we can identify what type of load must be there. There may be a question. From the by giving the shear force diagram as well as the bending moment diagram itself, what kind of load in between the region should be there? That kind of question may be asked. Okay, let's take if it's not given. Okay, let's take if it's not given. This is a cubic curve and this is the inclined line. Let's take this is the inclined line. Like that is given. Then maybe a question can be asked. So from this point to this point, I have a cubic curve in the bending moment diagram. So what type of load must be there? A point load or uniformly distributed load or uniformly variable load? Since it is cubic curve in the bending moment diagram, there must be a uniformly variable load. Just see that at uniformly variable load for bending moment diagram we have a cubic curve and it is an inclined line. What type of load must be there? So there must be a point load or no load must be there, so that you can have an inclined line here for bending moment as well as shear force also. Okay, it's a critical thinking question. You can find out by having the knowledge about the nature of curvature for beams in the shear force as well as the bending moment diagrams. Okay, I think you have followed this one. We will see in the next class how to draw the shear force diagram and bending moment diagram for a particular beam. Thank you all.